Hi everyone, this is Roberto Garcia here at the Analytical Instrumentation Facility, and I'm in the Hydra lab over in EB1. And today I want to show you how to basically do EDS using the EDAX Apex software. The first thing we're going to do is basically set up our sample in the Hydra. I'm going to assume that most people know how to operate the instrument and how to load the sample and set the working distance. First thing we'll do is wake up the system and turn on the beams and focus on the surface of the sample and link the stage. I'm going to be doing EDS, so I want to be at a voltage of at least 20 kV, which will give me the ability to detect about all of the elements in the periodic table. We want our current to be anywhere between 1 and 8 nanoamps, so we'll start at 3.2 and make adjustments as needed. That should give us plenty of signal. After linking the stage, we will go to 15mm working distance, refocus, and relink the stage. I can go to my eccentric position, which is 4.1 millimeters, and we can do EDS at this position. However, one problem is that you can't use the backscatter if you're going to be at 4.1 millimeters working distance, because it blocks the EDS signal. So if you plan to be using the backscatter detector, you'll want to be at least at a 6mm working distance or greater. We'll be using the backscatter today, so we will set our working distance for 6mm. Now I'm going to focus again and link the stage. Now what I need to do is find an area of interest, so I'm going to look around the sample, and here's kind of the area that I want to look at. Okay, I've got a nice combination of different faces present here. Now I can either continue with the Everhart detector, or I can go ahead and insert the backscatter detector to give me a much better contrast. So I'm going to do that now. Now the instrument automatically pauses the infrared camera when you put in the backscatter detector. So I just want to show you, I'm going to unpause the camera here so that you can see that the detector did go in, and thankfully it did not hit my sample. So from now on we'll just go ahead and use the backscattered image. You can see I'm getting a little bit more contrast in my image. Now that I'm all set with my detector here and my image, I'm going to go ahead and start the EDS. The software is called Apex, and the EDS computer shows up on the upper right-hand monitor. Double-click where it says Apex EDS and wait for everything to load up. As soon as you load it up, it's going to ask you to either choose an existing project. If you've made one before, go ahead and choose that one, or go ahead and create one. Let's create a project, and we're going to give it a name and give it a location to store all the data. The next thing to do is go to the File and Options, and here's where we're going to basically tell it how we want our images to save. Right now it's defaulting to JPEG, but we can change that if we want. We also want to put our image folder in so that anytime we save data or images, it will store in that folder. Now whenever we send images over or data, it will just collect there. Now that that's done, just hit OK. Now let's go over the menu here across the top from left to right. There's the collect image. If we go ahead and expand that out, it gives us options on the size of the image, how long to dwell, the signal to noise, and if we want to apply any tilt correction. This is where we would do it. We have our collect or go button for the collection of data. If this button is yellow, is a yellow dot, it means that the EDS detector just hasn't been cooled down yet. So all you have to do is push the yellow dot and wait for it to cool down. It should take about 5 minutes or so. This is the survey area to select the type of analysis that you want to do. Here you've got options to do either a spot, square selection, freehand selection, or you can even do a grid array of points. Then the quality, and when we talk about quality, it's talking about the resolution of the spectrum. Typically you're either going to be running in quick or standard. The only reason you want to go into high resolution is if you have some type of overlaps between peaks that you're trying to resolve. When you choose either quick or standard or high, it's basing the time constant on the amount of signal that it's getting. So if you want to make sure that you always keep the same time constant, you can go to manual mode and then go ahead and put in your settings there. You can also set your preset time and the resolution that you want there. Typically, it doesn't hurt to just go ahead and use the standard acquisition. Over here, the layout lets you arrange how your windows will be displayed. Drift correction is nice. It shows you how to use that. I'll show you how to use that later. Definitely, if you're going to be doing any type of mapping, you're going to want to do drift correction. Later, I will also show you how to generate the reports to get your data out and actually save the individual files from the data. That's a different area. Right now, we're in what's considered live mode. If we want to start to work with the data we have collected, we would switch to review mode here in the upper right-hand corner. Okay, let's get started. The first thing you want to do is collect an image. The other thing you want to do is insert your detector. Now, I'm going to purposely not insert my detector right now. It's retracted. What I'd like to show you is that if you ever forget to insert your detector, it's going to remind you and say, hey, your detector's out. Would you like me to insert? So let's go ahead. So now I'll collect my image first. What I should do is open this up and move my detector in. However, let's assume that I've forgotten, and if you forget and you push this collect button, it says the detector slide is not ready. Do you want to move it in before starting your collection? Just say yes. Then the detector will slide in and it will start the collection. Which is nice because not all instruments do that, and sometimes, believe me, you forget and you collect data as your detector's retracted. So here's our counts. We got lots of counts. Our dead time is 50%, which is okay. Probably a little bit on the high side, but not too bad. And it looks to me like we've got chrome, iron, cobalt, tungsten, nickel. There's some overlaps between some silicon and tungsten. There's also some manganese maybe present, but it's hidden by the chrome peak. Here's where it thinks that there's yttria, but there isn't any, so we can turn that off. Technetium, so here's where it's giving us options of elements by left-clicking on the peak. It's going to give us this little question mark here, and it'll tell me what elements are possible there. This one I think is off, so what I can do is just go ahead and take that out. Okay, so that shouldn't be there. I can go around and look at the smaller peaks and see if I want to include those. That's tungsten line. Okay, we can label that if we want to. I can click and drag and see what else is possible down here. Okay, that looks pretty good, so I'm going to reset my scale here. So we've gone over zooming in and also picking different elements that are present. We can do this by clicking on the spectrum. We can also just go to the periodic table. That will bring it up here. If we don't have ruthenium, we can just take that one off. There's probably some oxides and carbon on the surface here. If I want to include them, I can go ahead and include them, or I can exclude them. Okay, so this is what we've got. And so we can lock the elements, and that way they're always chosen. We've got our overall scan of the area, and we identified the elements present. Another method that you can use if you don't want to collect data from just an entire area is to do point selection or area selection. So what you can do is set up a couple of points to look at the EDS at a certain point, and then also small areas in all these different phases to see what elements are coming from those particular phases. Once you have that set up, you just hit collect, and it'll go from one point to the next area, and when it's done, it'll save everything. I'm going to show you now how to collect a map without drift correction. First, we'll collect an area scan and identify the elements present, or at least the elements that we want to scan for. After we've identified the elements, we will lock them in place so that we don't have to correct the element list again. So again, we're going to start off with our standard map. Right now it's saying it's going to take about 84 frames and 24 minutes to complete this map. Typically I like to go a little bit higher resolution map, so now if I change that, it says it's going to take 2 hours and 34 minutes. I'm not going to go ahead and run the entire 84 frames. Typically what I do is I let the frames collect to a point where I see a good definition between all the different phases and all the different elements, and then I'll stop the analysis. If you know that you get good data after 25 frames, you can set the frame time to 25, and then the software automatically stop at that point. Then you can just let it run and walk away and check your email for a period of time. The dwell time is going to be about 100 microseconds, and that's usually pretty good for the first time. This is all set on the standard parameters, so we'll just go ahead and do that this time. You can do the auto amp time. It's just one of those things, if you are going to have the same samples each time and run the same conditions, that should be okay. But if you want to make sure that you have the same amp time for each map that you collect, you'll probably want to go into manual mode and set it up there. There you can set up your resolution, your frames, change your dwell time, keep it consistent from sample to sample. So right now let's just go back to standard and we'll just do the standard run. Now it's going to take about 1 hour and 50 minutes. So we'll just go here and hit OK. And like I said, I'm not going to enable drift correction at this point. We'll just probably see some evidence of the drift later. Okay, we've got a couple of frames into this, and I'm just going to go ahead and stop it. We don't have to go and collect all the frames. I think we've gone through about 18 frames or so. I'm just going to go ahead and stop it after the 18th frame. And you can see here in this image that it's a little bit blurry, and that's because of the drift. Okay, so that drift is also going to translate to your maps. Now we'll go back to our live image once we've stopped the maps, and you'll see that when the image updates that there is quite a shift, so that's because of the drift in the sample. Okay, so now I want to rerun the same area with the drift correction enabled to show you the difference. So there's a couple of things I want to do first. I'm going to go back to look at my dwell time. Here, if you notice, each frame is taking a long time to collect because we have a high resolution image. I can go to a little bit lower resolution image to speed up the frame acquisition and keep the same dwell time, or I can keep the same resolution and use a shorter dwell time. What I prefer to do is use a shorter dwell time. You want to keep your frame rate short because the drift correction works in between frames. If it takes too long to collect one frame, you'll still probably see a little bit of drift in your image. So I'm going to go ahead and make my dwell time 50 microseconds. I'm going to keep everything else pretty much the same. Now I want to enable drift correction, and you'll see something happens to the image. Once I enable drift correction, the microscope actually drops down in magnification. It uses a wider area to basically check for the drift correction, and although we're still going to map the same area that we previously outlined. So now all I'm going to do is start this up. It's going to first take a look at the field of view, making sure that it can identify the particular area and that it has a feature to identify. And now it's going to start with its collection. And if you want, you can actually show the drift control. And what this will show you is how much and in what direction the drift is occurring. Now, I highly recommend using the drift correction if you want to make sure that you get quality data during mapping. Now you can see here in comparison the difference between no drift and the drift correction. And for the drift corrected image, we actually have double the frames because remember we reduced the dwell time on that one. Okay, now I'm going to show you how to run in batch mode. Batch mode is another great feature in this software. It allows you to run several areas automatically. And that means you can identify several areas that you would like to map and then run them after hours if you like, so without being present. To run in batch mode, you will want to select the manual option for the map. Here you can set up your dwell time. Typically, you're going to go with the fastest, 50 milliseconds. And more importantly, the number of frames to run before switching to the next area. Make sure that the drift correction is on. Now you're going to expand the menu under the batch mode button. The following process is very simple to add the different areas. You just go to the area that you would like to examine, take an image, make sure that the image matches the area exactly that you want to map, and then press the Add to Batch button in the upper left corner of the image, and it'll start to populate the list. You're going to continue to do this for all the areas that you want to populate the list with, and then after you're done, you're going to press the Collect button. The batch process will start. If you've selected drift correction, which I highly recommend, it'll do the drift correction. And then after it's done collecting, the instrument will shut down. So I've tested this out myself. It works great. Ran several areas. I think it was something like 10 areas, and then came in the next morning, everything was fine. If you really have a lot of areas to analyze, I highly suggest trying the batch mode. As far as data collection is concerned, I recommend making sure that at the start of the session to turn on the auto report. After an area is collected, it will automatically add it to a Word document. The document will be continuously appended until the end of your session. Then you can just save the file and have all of your data in one document for review. This will save you a lot of time in data processing. I'll go over data processing in another video. At this point, you should be able to run an analysis. Thank you.